Okay, so this tutorial we're going to review the basics of algebra, how to manipulate variables so that we can solve for one thing or another. The difficulty in this comes from not so much your algebra skills, but how we write equations in physics. We don't use x's and y's, we use other letters to stand for variables that represent actual physical quantities. And that, for whatever reason, confuses students at first because they're so used to x's and y's. So bear with this here, do the practice, and you should be in good shape because it's a critical skill for the rest of the year. All right, so let's start with something you should be comfortable with. Let's say we have the equation y equals 3x plus 2, where x and y are variables, things that you can change. You change one, you get something, another value for the other. So what if I want to rearrange and solve for x in terms of y? Okay, so I know x equals what? Well, you should be able to do this. I'm going to rewrite the equation over here, 3x plus 2. All right, so to isolate the x, I'm going to move the 2 over, so I'm going to subtract 2 by both sides. So I'm going to have y minus 2 equals 3x plus 2 minus 2. And I guess I did up there. And these cancel out. And now I'm going to divide both sides by 3, divide both sides by 3. We see the 3's cancel out, and I get a final result, x equals y minus 2 all over 3. All right, should be fairly simple. And if you still don't feel comfortable with that, or it's not come back to you, well, come and see me and we'll work on this and you should be fine. So if I substitute in y equals 5, then if I put 5 in here, 5 minus 2 is 3, 3 divided by 3 is 1, and I see that x is 1. And then I could go back up to the original equation, 3 times 1 is 3 plus 2 is 5, sure enough, it checks out. So in physics, these rules still hold, but like I said earlier, we use a more general form based on actual physical quantities. So take the equation y equals 3x plus 2. I can change that to v equals at plus u, where v stands for final speed, a is acceleration, t is time, and u is initial speed. In other words, this is a relationship right here where instead of putting in actual numbers, we're putting in letters to represent quantities. And then if we get values for those quantities, then we can solve for something else there. So for example, let's say a is 3. The acceleration of something is 3 units. The time it takes is 11 units. And the initial speed is negative 3 units. Then what must v be? Well, we can simply plug in the numbers. That's easy. So that would be 3 times 11 plus a negative 3. 3 times 11 is 33 plus a negative 3 is 30. So that's simple enough. V must be 30. That's not what we have to worry about here. What we want to be able to do is, suppose I'm given the equation, again, v equals at plus u, but now I want to rearrange it and solve for t. In other words, suppose I didn't know what a, t, and u were, but instead I knew what v, a, and u were, but I didn't know t. Well, I want us to be able to manipulate this equation like I did up here and solve for t. Okay? So it's no different than what we did before. So let me rewrite the original equation. Whoops. V equals at plus u. So I want to isolate the t. Okay? I want to get that by itself, where the a and the u just represent some numbers. We don't know what they are, but that doesn't matter. So the first thing I want to do, like before, is I want to get rid of the u. Okay, so I'm going to subtract u from both sides. So I'd say v minus u on one side equals at minus u, or plus u minus u, and we see the u's cancel out. And when you do this enough, you don't have to show me all that, because I know what it is. Okay, so let me rewrite that over here, because I know. So I have v minus u equals at. Now, since I'm trying to isolate the t, I've got to get rid of the a, so we should recognize, since we're multiplying by a, we're going to divide by a here, divide by a, and we see the a's cancel out, so let me write my final form. T equals v minus u all over a. Okay, that's what we want. So if I know how fast I'm moving at the end, how fast I'm going at the beginning, and the acceleration rate, I can figure out how much time it takes. So let's plug in some numbers just to verify. Okay. Oh, yeah, so for now, any given value of u and v and a, we can solve for t, the time for an event. All right. So here's what I want you to do. Well, I'll do a few more here, and then I'm going to give you some practice on your own. So for the following equations, to manipulate the appropriate variable for a new form of the expression. So suppose I start off with the equation v equals distance divided by time, or d over t. Rearrange this to solve for d. In other words, d is what combination of v and t. All right, so let me rewrite the equation. And I'm not going to use a slash, I'm going to use this. All right, so v is distance divided by time. I have to isolate the d, so I got to move the t over to here. Well, what do? Well, hopefully you recognize I simply multiply both sides by t. T's cancel out, and my final expression, d equals v times t. Boom, we're done. Okay, so if I have actual values for v and t, I can plug them in. So d would be equal to v, which is 3, times t, which is 9, and that would be 27. Okay, and if I go back over to here, if I put in 9 for this, that would be equal to 27 divided by 3. So they're consistent with one another. The one thing that I'm not doing here that we will have to do for class is we have to put units in there. It's not just 27 a number. There's got to be some units like seconds or meters per second, etc. Okay, now let's rearrange the same equation for t. So let me rewrite what I had over here. Our final value was d is v times t. Okay, now let's take our original equation, v is d divided by t, and solve for t. Now here's where we got to be more careful. We got to recognize that our variable is in the denominator of this fraction. So I can't leave it in the denominator. I have to move it to a numerator. The easiest way to do that is to cross multiply like this. So I can write v times t equals d times 1, or just d. In fact, that's the same thing as we have there. Now I can move the v over, divide both sides by v, and I've got t equals distance divided by speed. Okay, to check out if that's a valid equation, if v is 4 and d is 16, what is t? Well, t is distance, 16, divided by v, speed 4, which is 4 units. And if I go back to the original equation right here that I've got crossed out, if I put in 4 for v, and I put in 16 for d, and I put in 4 for t, 16 divided by 4 is indeed 4. So I know I've done the algebra correctly. All right, so hopefully this is making sense. All right, so let's do more practice. So what I want you to do is I'm going to pause. I want you to try 1a and b on your own, okay? Where you're going to take this equation, manipulate it, solve for in terms of m, and then plug in numbers to see if it checks out. If you do it right, you should get the answer 4. So I'm going to pause right now. You try this on your own. When you're done, restart it, and I'll show you the solution. Okay, so hopefully what you did is maybe I'm going to rewrite the equation. A equals f over m. I want to isolate the m. I see that the m is in the denominator, so I don't want to just divide both sides by f. That's a mistake. I want to cross multiply. Okay, so I'm going to say m times a equals f times 1. So there's that. Now I can solve for m by dividing both sides by a, and I have m equals f over a. All right, let's see if that checks out. So if a is 1.5 and f is 6, 6 divided by 1.5, f over a, is indeed equal to 4, and we're good to go. Okay, now try the next one. All right, so let's see how well you did. The squared shouldn't throw us off too much, but let's see what we have. So first of all, I want to move the half over. So I can divide both sides by a half. I'm not going to actually do that. I'm going to just multiply both sides by 2. So let me rewrite the equation. K equals 1/2 mv squared. So if I multiply both sides by 2, I get rid of the half. So multiplying by 2 divided by a half is the same thing. Now I want to move the m over, so I divide both sides by m. So I have that. So let me rewrite it. Now I have v squared equals 2k all over m. Now, how do I get rid of the squared? Well, the opposite function or the inverse function of squared is square root. So if I take the square root of this and take the square root of the whole thing, then I get v equals square root of 2k all divided by m. Okay, so check using values. If I put in 1600 for k, so let me do this off to the side here, 1600. I put in 200 for m. This is multiplied by 2, square root. Let's see, 2 times 1600 is 3200. 3200 divided by 200 is 16. and square root of 16 is 4. And that's what we should get right there. Okay, so come in with questions if you're confused by any of this, but your homework is to solve the rest of these problems right here. Now I want to make sure you know what we're asking for. So if I start off with the base equation, p equals v squared of r, I want you to rearrange it and solve for r, and then plug in the following numbers and get a value. And if you get the right answer, you should come out to be, looks like 0.5. Okay, if you don't get 0.5 when you do the numbers, you've got the wrong equation, retry it. Okay, don't give up. Then take the same equation, rearrange it and solve for v, plug in numbers, and you should get a value for v right here, and then check it down there. And do that for numbers for a and b. And at this point, we hopefully will feel more comfortable with physics algebra as opposed to math algebra. Same rules, same process, it's just we don't use x's and y's very often.